Good morning, everybody. Hope everyone is doing well. I know we are, we're on a little vacation here, but I decided to go ahead and put up this worksheet, solving quadratics using the quadratic formula. All right, I'm expecting you guys to watch the video, find some time today or tomorrow or before the next meeting, and review the odds. The next time I meet with you, I will do the evens, and we'll have expected you to kind of listen to the video at some point and go through the odds, okay? Make sure you understand it. Now, one of our next lessons, or 2 lessons from now, we're going to solve quadratics by completing the square. Then I will be able to demonstrate to you how they came up with this formula. I'm excited to do that for you. But right now, there is a formula for solving a quadratic. Now, we learned solving quadratics by factoring, solving quadratics by taking the square root. And now we had to figure out a way to solve a quadratic when you cannot factor, all right, or take the square root. So this is the technique. Now, when you're solving a quadratic, remember the quadratic is written in this format: ax squared plus bx plus c equals 0. All right, so we always say that a is the number in front of the x squared term. We say that b is the number in front of the x term, and c is always the constant. All right, so if we look at question number 1, we would in fact say a, there's a 1 here. So we would say a equals 1. That's a -1. So b equals -1, and c equals -4. So we're now going to go to the formula: x equals -b plus or minus the square root b squared minus 4ac all over 2a. And I always tell everyone at first, you should go ahead and just write the formula every single time that you do it, and that will help you to memorize it. So again, once you have the formula written down, now it is just a matter of taking and substituting in for a, substituting in b, and then substituting in for c. And here, I forgot, here's a right there too. So you're just plugging in those numbers, and then we're done. Okay, so x equals -1 plus or minus -1 squared minus 4 times 1 times -4 all over 2 times 1. Now you just simplify. Simplify what's under the radical. So if I do that, x equals, now -1 is +1, plus or minus the square root. -1 squared is 1. -4 times 1 times -4 is a +16 all over 2. So now I can just write 1 plus or minus the square root of 17 all over 2. And we're done. So very easy plugging numbers into a formula. Let's check out number 3. All right, for question number 3, a equals 3, b equals -11, c equals -2. Write the formula: x equals -b plus or minus square root b squared minus 4ac all over 2a. Now again, x equals negative 11 plus or minus negative 11 squared minus 4 times 3 times negative 2 all over 2 times 3. X equals 11 plus or minus 121. 4 times 3 is 12. 12 times 2 is 24. 2 negatives, positive, all over 6. So x equals 11 plus or minus the square root of 145 over 6. Now, one thing I want to remind you of is we have to break down square roots if we can. So in order to break down the square root, I've got to see if there's a perfect square. So I know 145 is divisible by 5. So 145 is the same as 5 times 29. Because 29 is prime and 5 is prime, it doesn't break down anymore. Therefore, there are no more perfect squares. And because there are no perfect squares, we say this is my solution. Okay, that's my solution. Hopefully that's making sense. Now, let's take a look at number 5. Again, I recommend that you write A equals 6, B equals 4, and C equals negative 1. So now X equals negative B plus or minus B squared minus 4AC all over 2A. So X equals negative 4 plus or minus the square root 4 squared minus 4 times 6 times negative 1 all over 2 times 6. Let's see how we can simplify that. X equals negative 4 plus or minus 16 plus 24 all over 12. X equals negative 4 plus or minus the square root of 40 all over 12. Now we can look at 40 and we can say, okay, I know that breaks down. So let's go ahead and review that. Negative 4 plus or minus. 40 is 4 times 10. Now we wouldn't say 2 times 20 because 2 is not a perfect square and 20 is not a perfect square. We chose 4 because 4 is a perfect square. Now we can just simplify that to negative 4 plus or minus. Now we ask a question, what is the square root of 4? And that's 2. 2 radical 10 over 12. And now we divide everything. This we can divide by 2, this we can divide by 2, and this we can divide by 2. So because we can divide everything through by 2, we can simplify. Negative 2 plus or minus, I'm just going to write the 1, even though it's not necessary, and this is a 6. Notice we don't divide an irrational number, which is the radical. We do not divide that by 2. All right? Only the rational numbers are being divided. Okay. So if you need to stop and pause the video and go back and listen to it again and make sure you understand the process of the substitution and then the process of breaking down the radical and then the process of reducing the fraction. Those are all critical things that you're supposed to be able to do. So now let's look at question number 7. Again, my advice is to say A equals 1, B equals 6, C equals 3. So X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So now x equals negative 6 plus or minus 6 squared is just 36 minus 4 times 1 times 3 all over 2 times 1. X equals negative 6 plus or minus the square root. Now we just want to do what? Simplify that. 4 times 3 is 12. 36 minus 12 is 24. No reason to delay that. All over 2. And now you're supposed to look at the 24 and say, hey, that's a perfect square in there. So we could say x equals negative 6 plus or minus 4 times 6. And then you have to go back and tell me, well, what's the square root of 4? Square root of 4 is 2. So we can say 6 plus or minus 2 radical 6 over 2. And now we divide negative 3 plus or minus 1 radical 6. And that is our answer. Very nice. Again, remember, the most important thing is making sure you're understanding the substitutions. Once you understand the substitutions, you understand the arithmetic, and then you need to check out the radical, see if it's a perfect square. If there is a perfect square, you have to simplify the radical and then reduce the fraction, okay? So again, don't be afraid to repeat the question. Go back, stop the video, make sure that you're understanding. Once you do it 10 or 15, 20 times, it'll be easy for you. Over here. All right, now we're going to say a equals 2, b equals negative 10, c equals negative 1. So now x equals negative b plus or minus b squared minus 4ac all over 2a. So x equals 10 plus or minus negative 10 squared is 100 minus 4 times a times c all over 2 times 2. X equals 10 plus or minus the square root. Now we can do the math here. 4 times 2 times 1 is 8. It's positive. So it would be 108 all over 4. Now, a long time ago, we talked about 108. Now, 108, I tried to tell you, the easiest way to do it is just say 36 times 3, because that's the largest perfect square in 108. So 108 breaks down to 6 radical 3. Now, if you didn't see that, you might say, well, 108 is also 9 times 12. Well, then you get 3 radical 12, but then you have to break down 12. And then that would be 4 times 3, and then this is square root of 4 is 2. When you pull it out, you multiply, so you get the same answer. But again, to simplify the process, we try to find the largest perfect square, okay? Now, we know that 108 is 36 times 3. We'll go x equals 10 plus or minus, and I'll just write that step in there. 36 times 3 all over 4. And now what I want you to be able to tell me is the square root of 36 is 6. So we say x is equal to 10 plus or minus 6 radical 3 all over 4. Now what I want to do for you is I want you to see this 10, this 6, and this 4 can all be divided by 2. So I want to divide by 2. I want to divide this by 2 I want to divide that by 2. I want to divide this by 2. And when I do that, all right, that's simplifying the fraction properly. Okay. So that's going to equal 5 plus or minus 3 radical 3 all over 2. And then we would say that is our answer. Okay. Now, once again, don't be afraid. Pause the video, go back, look it up. All right. If you're having questions. Now, the next thing I did was I made a worksheet that mixed everything up. So there's solved by factoring, solved by taking the square root. There's solved by cross multiplying, all kinds of things, all right, that I want you to be able to do. You have to make a decision now. And I'm going to try to show you where you can perform what, how you want to do the problem based on the equation. All right, so let's start first with number 11. Now, number 11 is just x squared, and that's it. So this is a super easy problem because to undo a square, we just take the square root. Now, I often tell kids that the biggest mistake is that they forget plus or minus, right? Because 5 squared is 25, and negative 5 squared is also 25. Okay? Let's look at number 13. Now, number 13, a prime candidate for factoring. Everybody should be able to look at that and say, well, it can factor. So what I want to do here is 2 sets of parentheses, x times x, factors of 12 that make 1, 4 and 3. And I want the 4 to be negative and the 3 to be positive. Because don't forget, negative 4 times positive 3 is that negative 12. And then if I were to multiply this out, that's negative 4, positive 3, negative 4, positive 3 is negative 1, which is this middle term. So then once you get it factored, you set the factors equal to 0. So x is equal to 4 or negative 3. Hopefully you feel good about that. 15. Now again, a little bit different, but I see the square, okay? Because I see that square term right here, I can easily undo the square by doing what? Taking the square root of both sides. All right, now what happens to squares and square roots? They cancel each other out. So now you write x minus 5 equals, remember with a variable, when you take the square root, it's plus or minus the square root of 6. It doesn't even have to be a perfect square. Remember, your ultimate goal is to isolate the x. So now I have to get rid of minus 5 by adding 5 to both sides. Now keep in mind, when you do that, these cancel. These two things you cannot add together because one's rational and one is irrational. So we say x is equal to 5 plus or minus the square root of 6. All right, good example problem. Now, put a star by this one because once again, you should be able to say, well, just take the square root. The problem is when you take the square root, what's underneath the radical cannot be negative. There's no number squared that will equal negative 4. So for number 17, we just say no solution. All right, so please try to make a mental note of that. When you take the square root, what's underneath the radical cannot be negative. All right, now I'm looking at 19. All right, it's not just a square term because there's a 3x. No factors of 9 make 3. So I know I have to use the quadratic formula this time. So I'm going to write a equals 1, b equals 3, C equals negative 9. X equals negative b plus or minus b squared minus 4ac all over 2a. So x equals negative 3 plus or minus 9 minus 4 times 1 times negative 9 all over 2 times 1. So now x equals negative 3 plus or minus, let's simplify this, 4 times 9 is 36. That's going to be positive. So I know 9 plus 36 all over 2. So now x equals negative 3 plus or minus the square root of 45 over 2. Now we're back to almost the final stage where you have to look at the 45 here and say, hey, 45 is 9 times 5. Square root of 9 is 3. There we have it. So now negative 3 plus or minus 3 radical 5 over 2. Now notice here, this 3, and this 2 do not share a common factor, so that is your final answer. Okay, let's check out 21. Now for question number 21, this one's a nice problem because this one's not even a quadratic. And how do I know it's not a quadratic? Because there is no x squared term. All right, and because there is no x squared term, we just have to solve it just like we did in chapter, I think 1, we solved equations. So here we go. 4x minus 10 equals x plus 2 minus x plus 10. So now we have 3x equals 12, so x equals 4. Again, the reason why I put that in there was to show you that it was possible that you don't always get a quadratic now. You have to always be thinking about each problem and how you solve it. Is there a square term? All right, if there is a square term, then you're going to solve some way with factoring. You can do square root, or you can do quadratic formula. All right, now let's knock out 23. Okay, now the next problems are a little bit hard. All right, so I want you to really concentrate on what I'm talking about here. All right, now this one, all right, is particularly tricky because I have to multiply this out first. All right, there's no way for me to isolate the x. So what I have to do is I have to multiply x minus 5 times x minus 5 and then combine terms. So if I do x minus 5 times x minus 5, remember, x times x is x squared, negative 5x, negative 5x, and then negative 5 times negative 5 is positive 25. So x minus 5 squared is the same as x squared minus 10x plus 25. All right, so this simplified to that. So now I'm going to rewrite the problem as x squared plus 9 equals x squared minus 10x plus 25. Now, the reason this problem is actually kind of easy is because if you'll notice now, this x squared and this x squared, if I combine them, they cancel out. In other words, if I was doing a minus x squared and a minus x squared, you see what happens, right? They cancel out, which is good now because now it's no longer a quadratic, it's linear. So 9 equals negative 10x plus 25. Subtract 25 from both sides. So I have negative 16 is equal to negative 10x. Divide by negative 10. All right, and then I reduce that. All right, divide by 2, 8/5. All right, so that one was tricky because we started out thinking it was a quadratic, and in fact, it was not a quadratic. All right. It just became linear because the quadratic term or the square term canceled out. So please review number 23. All right, please review number 23. I also want you to review question number 25. Because again, it's kind of the same as we did up here. You had to expand that out. Same thing here. We have to expand out x plus 5 or x plus 6 squared. So again, let's practice. X plus 6 times x plus 6. X times x is x squared. Positive 6x, positive 6x, and then a positive 36. So that becomes x squared plus 12x plus 36 plus 2x minus 2 equals 13. All right, don't forget, I just distributed the 2 here. And that's how I got the 2x minus 2. Now it is a quadratic, so we're going to go ahead and combine terms. So I'll break that down and do that slowly for you. All right, there's nothing I can combine with x squared, so I'm going to leave that x squared. Now there's a 12x and a 2x, so that makes plus 14x. Then there's a positive 36 and a minus 2, which makes a positive 34 equals 13. Now, we do have a quadratic, so quadratics always have to be set equal to 0. So I have to subtract 13, and now I have x squared plus 14x plus 21 equals 0. Now, there aren't any factors of 21 that make 14, so I can't factor it, so I'm going to use the quadratic formula. So we're going to write a equals 1, b equals 14, c equals 21. Write the formula, x equals negative b plus or minus the square root of b squared minus 4 ac all over 2a. So now I have x equals negative 14 plus or minus the square root. Now, of course, we all know 14 squared is 196 minus 4 times 1 times 21 all over 2. 2 times 1 is 2. All right, so we'll finish this up now. X equals negative 14 plus or minus the square root of 196 minus 84 all over 2. X equals negative 14 plus or minus the square root of 102 all over 2. And now I'm thinking about 102, and I know 102 is 2 times 51. 51 is 3 times 17. So there is no perfect square there, all right? There is no perfect square. So we can just leave it as our answer. We can't break 102 down. Now the next thing kids try to do is they try to simplify the 14 and the 2, and we cannot reduce that because of the addition and subtraction. We say you cannot reduce through addition and subtraction. The only way you could reduce is if there was a number in front of the square root that was divisible by 2, okay? So again, we're almost done. All right, let's look at 27 now. All right, for 27, we want to isolate the square term, which is the x plus 4. So I have to get rid of the divided by 3. So to get rid of the divided by 3, I'm going to multiply both sides by 3. And I have x plus 4 squared equals 24. And then what I do is I take the square root of both sides. So I say x plus 4 equals, don't forget, plus or minus the square root of 24. Then what we do is we say, okay, 24 is a perfect square. 4 times 6. Square root of 4 is 2. So 2 radical 6. So x plus 4 equals plus or minus 2 radical 6. And don't forget we subtract 4. And we say x equals negative 4 plus or minus 2 radical 6. Okay, so again, it's a little bit different because you had to isolate the square. All right, so you had to undo the division. But it came in handy understanding that if you just have a square term, you're allowed to take the square root. Much easier, okay? Now in this one, what's going on is we have a square term, there's no other x term, so we have to isolate. So we would just do what? Add 6 to both sides, 3x squared equals 30, divide by 3, x squared equals 10. Now we take the square root, so x equals plus or minus square root of 10. And that's it, that's the odds. Okay, so for those of you guys who joined me, or if you're just listening to the video, the next time we meet, we will go ahead and go through the evens. Now I am going to expect that you have tried the odds. So we should be able to rapidly go through these problems and let me help you where I need to help you. But right now, all right, I want you to listen to the video carefully, go back over the video, practice the problems. Again, quadratics is very, very big topic, all right, that are on all the standardized tests. They're always on the entrance exams, always on SAT, ACT, a big part, all right? So please go back, think about these problems, and study a little bit. You've got nothing but time on your hands, all right? Please study. Hopefully you're having a nice day and that everyone's staying safe and healthy. I hope to see you in person soon, but I am not sure. So God bless and see you soon.